And so those three required ingredients are labeled data. We agree that it's mostly labeled data, not just unlabeled data, though there are a few exceptions, like word vectors, that you can learn from large unlabeled text data. How to get that data is actually an interesting question, and I'll touch on that in a little bit. The second major ingredient that led us to these breakthroughs and all these new conferences and old conferences like NIPS and ICML blowing up in size are deep learning algorithms, mostly recurrent and convolutional neural networks. And then the last and third ingredient is multi-core compute. Mostly those are NVIDIA GPUs at this point, and I'll see a bright future ahead for NVIDIA, but in many cases, we can also see how this compute and the GPUs are mostly commoditized. So I won't focus too much on this in this talk. But those are just the three ingredients that led us to the breakthroughs in research. Now, what does an actual org structure look like for companies to make this into successful products? Where are the actual people, and what do they do when we move this research into production? And there, the truth is that while in many cases it starts with research, especially for large organizations, especially as you're trying to create completely new applications, once research is done and we created new algorithms and models, optimized the optimization algorithms, understood regularization better of all these very powerful deep learning models, it then actually comes to be a real engineering challenge. And in many cases, the engineers have to first work with messy real-life data, integrating it from different places, cleaning it. In some cases, it's also up to them to label it if we want to give pre-trained classifiers to people. Then they do need to still deal with the hardware infrastructure. Then, and this is often a big deal, they have to have load balancers and everything for scaling and providing easy-to-use APIs. There has to be good documentation for them, especially when you want developers to use your AI tools. And lastly, and this is very important, you have to really think about trust and security. There are permission schemes. If you have a large amount of data in your organization, not everybody's supposed to see every aspect of the data in some cases, and you really have to carefully think about that. Trust at Salesforce is our number one value too, and you cannot forget about that. But that's also only step two, and once you actually want to fully make it successful, you have to carefully work also with product groups. They really have to think about the workflow integration, and that's the last major piece. You have the algorithms, the data, and the workflow integration, and these are usually the three groups that will work on that. And workflow integration, sometimes, especially the more technical you are, you tend to forget about it. You just say, hey, there's this amazing AI feature. Obviously, everybody will want to use it. And then users might feel like they're training their own replacement, and they don't want to use it. And then it's actually very much a UI problem. You want to make people feel empowered, enhanced, augmented in many ways, instead of feeling replaced. Then you also need to be very creative in finding some of the applications, in computer vision, for instance, but also in text. And sometimes you need to be creative in understanding where your algorithms will actually fail. So, for instance, machine translation is not yet perfect. We cannot translate as well as people. Yet we found that if you give human translators a raw translation of a text, they will actually be much faster in just fixing that one up instead of having to go from the completely raw text.